So I've started recording the meeting, so we just comment immediately. Again, thanks so much everyone for joining in tonight. We are looking at a 3 day session of data analytics workshop. Today, I'm going to be looking at data preparation, basically what we can use Python to do regarding data analytics. Some of us probably we are joining this call, we are students, some might be workers, some are already people that are using data in their working place, some are already using tools like Excel, SQL for data analytics. So this particular workshop, this particular session is going to focus on using Python for data analytics. And then we are going to be leveraging on Visual Studio Code. Most people, whenever you start programming, let's say in web or desktop development or mobile development, what you use most times is Visual Studio Code. But people usually see Visual Studio Code as not a tool for data science. They go to some other platforms, probably using Colab or some of all these other online platforms for running data analytics. So today I'm going to be walking us through how we can use Visual Studio Code for data analytics, and then we'll be doing some practical sessions to see that it's much more easier and then really interactive and fun to use Visual Studio Code for data analytics. Again, without wasting much time, so let's just proceed into it. So as I mentioned, we're going to be looking at how to manipulate and clean data. That will be our first session, and then I'll be taking this session. My name is Samuel Adeshola. I'm a beta student ambassador at Abubakar Tafawa Balewa University. So if you are joining this call today, I'm assuming that this is not your first time of doing Python. Even though you don't have, even if you don't have understanding of Python before, probably this is your first time. At least this can be a boost, or this can be an encouragement for you to go and learn Python. So, but what we're going to be using in this class, that we're not going to be doing from scratch again. Python is there. Also, Visual Studio Code. If you don't know about Visual Studio Code, probably this is your first time. You can just go ahead and download it. But we're going to be using Visual Studio Code in this class, and I'm assuming that you already have a little bit of understanding of Python. Or if not, don't worry, you can still follow along with the class, and later on you can download Python and start learning afresh. While setting Visual Studio Code, there are some things that we are going to need. The first one is Python extension. If you're using Visual Studio Code, you should have known about extensions for Visual Studio. If you're programming in C++, you have to download extension for C++. If you're programming in things like PHP, CSS, or JavaScript, you might need to download extensions for those programming language. So the same thing, if you want to program in Python using Visual Studio Code, you also have to have the extension for Python installed on Visual Studio Code. So again, assuming you have this already, but if you don't have it, don't worry. I said I'm going to make this slide available for us, and then we can use this link to set up our Visual Studio Code for Python. Another thing is Jupyter. Jupyter is a notebook, a form of tool that's very good for processing our data and then analyzing our data. Another thing is Anaconda, and then lastly, a data science environment in VS Code. I won't really take much time in setting this up, but I'm going to be making this available for us so that we can go straight into the workshop immediately. So what are the things we are going to be doing in this for today's session? So we're going to be looking at pandas and data frames, and how we can use data frame to manipulate our data. We also have general understanding of how data frames work and how we can combine our data sets. Also, we'll be looking at how to identify and remove duplicates. If you are dealing with a large volume of data, you usually have cases of duplicates, cases of empty value. We'll be looking at how we can remove those ones and then add them appropriately. We're also looking at how we can undo null values and duplicate values, as I mentioned. And the most important part, we're going to be analyzing the data. We have a data that we are going to check, and then we try to make sense of that data. It's a form of business data. We try to make sense of it. We generate some meaningful insights from that data using exploratory data analytics. So let's just go straight into it. Again, we don't have much information. I want to tell you that if you are handling real world data, it can be messy. It's not usually clean all the time. Let's say you are taking a survey from a set of people. Some people might just choose to omit some part of the survey without filling it. Some might fill some part. Some might even give you bad value. Where you are supposed to type name, somebody might just put number there. So when you are dealing with data in real life, it's usually messy. It's not exactly the same way you want it to be. So it's very important that whenever you have your data, the first thing you do is to clean it. In the life cycle of a data, or as a data analyst, where you spend most of your time is usually in data cleaning and preparing the data. To generate graphs or insights from data, it's not usually complicated. But when it comes to cleaning the data and making it ready for analysis, it's usually bulky. You spend up to 70% of your time trying to clean your data and prepare it for data analytics. And if you are looking into the world of machine learning, artificial intelligence, they said your data is as good. I mean, your model is as good as the data it was fed on. So if you serve your model a bad data, they're going to have bad results. And if you give your data good, if you give your model good data, you have good model. So you have to make sure that the data you are feeding your model is very good, so that you won't be getting a bad output from your model. So don't forget, the first thing we have to do is to clean our data, and we're going to be seeing how all this can be done. Again, we are going to be exploring our data frame. We're going to be looking at the concept of data frame and how you can make sense and make more meaningful insights from it, and how you can use it to ask our data set questions of what we need, how we can generate some meaningful insights, something like differential, like there are these concepts in statistics that this with analysis of data. We have differential statistics, and then we have explorative statistics, we have inferential, and then we have descriptive. So you'll be seeing how we can use data frames to generate all these insights. Again, as I mentioned, we are going to be working with how to undo missing data. If you are trying to analyze the data and then you have some cases whereby some data are missing, how do we undo all this scenario? And we are going to be using four different functions. We'll be checking if a particular cell is null, meaning that if there's no data point there. We'll also be checking if it is not null, that's if there's actually data where in the set that we are dealing with. Also, we'll be seeing how we can drop non-numbers, and then we can also fill them. We'll be looking at all these principles and all these functions, and now we can use them to better prepare our data for analysis. So the key takeaway I want us to take before going to the practical session is that there are multiple ways of dealing with data when it comes to preparing the data for analysis. Sometimes if you have cases of duplicates, you can choose to remove the duplicates. If you have missing data, you can choose to remove it, or you can choose to fill it with a particular number. So all this is actually dependent on you as a data analyst, and also based on the data that you are looking at. Sometimes it's good if you fill the data with, if you're looking at a large volume of data, you can just choose to remove the duplicates or the missing values completely. But sometimes the data you're looking at is very small, so you don't want to be removing what is not even there at all. So you want a way that fill up your data instead of removing the duplicates. So that's another way of dealing with duplicates and null value. So one thing I want us to do is that as a data analyst, you must have this thinking around how best you can handle your data, because it's not enough for you to know how to write the code or for you to know how to use the tool. You also have to know what to do most times. If you don't know, if I give you a set of data or a data set and then you don't really know what to do with it, the code is not going to tell you how to handle your data. Python will not tell you that. Visual Studio Code will not tell you that. It's not left to you as a data analyst to know what you do with that data that you are looking at. So sometimes it's good. There's not a certain rule that you can always use, that whenever you have missing data, you have to remove the whole row or you remove the whole column. So it's dependent on you. If you have some missing values, do you want to fill it up with some values, or you want to remove it completely? Also, if you have duplicates, it's also dependent on you that to make the decision whether you are going to remove the old duplicates or you're going to leave them in data sets. So please think around this line and how you can handle your data. The scenarios usually varies from one data set to another. Sometimes the best is for you to remove them. Sometimes the best is for you to fill them up with a particular value. Sometimes if you have duplicates, it is best for you to remove the duplicates, or it's best for you to just leave it there. So you can't really say this is what you should do at all time, but just know whenever you're handling your data, depending on what you're looking at, it might varies. But one thing I want us to think about is the concept of having large volume of data. Most times, if you have a large volume of data and then you are looking at missing values, you can just remove the row or the column, because we have a lot of data. We can always remove one, and then it won't really affect our data. And if you're looking at a small amount of data, just a small volume, you might want to fill those missing points with values instead of removing them completely. So just take note of that. As I said, there's not a single rule that should be applied. It's just dependent on data. So we are going to be looking at how to identify duplicate data when we go back to the workshop, and then we're going to be seeing how we can handle them as I mentioned earlier. So I don't want us to stay much time talking about the theory. I want us to go to the practical since this is a workshop. Now, yes. So after you've pick up your data, probably from your working place, from an analysis in the lab, some business data, some social data, or in community data, or maybe even that relates to weather or environmental conditions. You can't just, after cleaning your data, you can't just leave it like that. If you want to make presentations to stakeholders or to business executives or to superiors, it's best that you analyze that data and then you make meaning from it. That's the major point. So I had to rush through the previous things so that you can come to the major things. So you have to analyze the data to make the meaning from it. For example, what's the meaning of mean? If you say the median of this data set is this, what does it mean? What does the meaning of what's the meaning of median? If you say the standard deviation is this, what does that mean? Actually, if you say the variance of the data set is this, it actually make a particular sense. You're not just doing some calculations that doesn't make sense. All those things actually make sense. So it's now up to you as a data analyst to present your data in such a way that it's much more easier for someone that's not even in your field at all to understand it. So that's where exploratory statistics and visualization comes in. Sometimes it's best for you to use pictogram to represent your data. Sometimes it's best for you to use histogram. Sometimes it's best for you to use pie charts or bar charts. So you have to be able to present your data in such a way that it makes sense to people that you are presenting it to. And that's where data analytics come in. Also, as I mentioned, you must be able to make sense from the data you're looking at. If you are collecting weather data, let's say rainfall data over the past 5 years in a particular location, you must be able to make predictions from that data that, okay, based on the data you've collected over the past 5 years in this particular geolocation, this is how rainfall will behave in the next 2 years or in the next 3 years. So that's where data analytics come in. So as a data scientist, as a data analyst, you must be able to make sense from your data. Though we are not going to be looking at descriptive statistics or inferential statistics today, we are going to be looking at how to use the tool, that's how to use Python. But you have to know that what you have to do as a data analyst is know what to do with the data and how to make sense from the data. If you have a data, you have to know, should I calculate the mean or the median? Should I find the variance or should I calculate the standard deviation? So it's up to you how to know what to do with those things. But we're going to be looking at how to do those things in this session. So again, I'm going to be making this slide available for so that we can click on this link and then learn more from the resources that we have on those links. So immediately I'll just go to the practical session so that we'll be learning in the process also. So I'll share my screen now. Yes. So yeah. So I have Visual Studio Code here. That's the tool that we are going to be using. Again, as I mentioned, before you can start using Visual Studio Code for data analytics, there are some things that you have to do regarding setting it up. If you are just downloading yours today, the first thing you might want to do is to come to extensions over here and then search for Python. I will not be walking us through this. If you have any question regarding this, you can maybe send a personal email or reach out to me personally. So you can, if you search for Python, and it's much more easier for you to get this done. Download Python as an extension of Visual Studio. Another thing you have to do is to set up Anaconda environment. But again, I'll not be those things really take time to set up, so I will not be capitalizing on them for this session. But the most important thing that you have to do is to set up Anaconda environment. which is where we have to, that's where we are going to be saving all our modules. If this is your first time of doing Python, this might sound strange, but if you have been learning Python before, there's something we call virtual environment in Python. Virtual environment is basically, a virtual environment, not really the main environment, where you can install what you need at that time. So let's say you are doing a particular work now, and it requires a particular software, version 1.0, and then you have another work tomorrow that requires software 2.0. So if you are going to install the two on the same laptop, it will start conflicting each other. So what virtual environment does in Python is for you to create a separate environment where you can install all your things and to not affect what you are doing tomorrow. So after you are set up a virtual environment, I don't want us to look at all those things today for this particular session because it's going to take much of our time. And then, but just know that from the slide that I shared, the link at the very second slide will walk us through how to set all these things up on our laptop and to get us going in no time. So let's just go straight into the session. Now, I was thinking when trying to prepare data set for this tutorial, if you should look at some complex data sets online or some data that we collected ourselves and try to analyze it. But I was looking at a data set that will be available for all of us to use. And one very good thing that some of the modules in Python for data analytics gives us is some inbuilt data. There's some data already in the system that you can try to use. So you don't have to maybe worry about downloading the data sets or downloading another softwares online. If you have some tools like Pandas and NumPy, as I mentioned, if you have not done this at all before, from the slide I'm going to share with us, the second slide talks about how to get all these things installed. But the major point of this class is just to look at how we can analyze data. So we don't want to pass through the stage of setting up our laptop from the scratch again. Now, one of the very common tool in Python for data analytics is Pandas. So how do we bring in Pandas? You can say import. I'm going to be typing all this here, so but it's not going to take time. Just I want us working through it together. So import Pandas as PD. Pandas is the module that we're using, and then I'm calling it PD. So that whenever I want to use the module, I can just reference PD instead of saying Pandas. Another thing we want to use is iris datasets. This is data analytics workshop, therefore we need datasets. As I said, I don't want to maybe go online and pick some new data. Though we are going to be using some data online when it comes to visualization, but for the preliminary part, let's just use data that's already available inside a particular module. So inside the scikit-learn module, there's a data set there called the Irish data set. It's a data set that analyzes flower. This data set is on Irish flower, I think. So let's bring this data into our environment. So it's from sklearn. So there's some data sets inside sklearn. So I'm going to pick in from sklearn.datasets. Then I import the load iris. So I have the data set now. Then I can prepare it. So let me give the data set a name. So even if I want to use it, I'll just call it the name. And I'm giving it iris now. So iris is equal to load iris. Don't forget I've already imported it from this line. So I'm just bringing it up here. Load iris. Now, when I was giving the presentation earlier, I talked about data frames, and now we can use data frames to analyze our data and the opportunities that data frames give us. So most times, whenever we have data, we can, if I load this and I type iris, I can see this iris. But you looking at this now, it doesn't really make sense. It's just some bunch of data. Maybe for you as a data analyst, you understand what this means. But even for who is not a data analyst, you might not know what all these things mean. Like, what are you even looking at? What am I looking at? So one thing you have to do that's very important, and we also give streams for what we are about to do in the future, is to put this in a data frame. If you check this particular data now, it's just numbers. We don't even know what these numbers mean and what the numbers are. So it's better for us to put them in a data frame and then we can analyze them one after the other. So I can call it iris data frame. That's iris df. And then I've used this particular module, this pandas module, to create a data frame. So how do I do that? So I have my pandas, which is PD that I've already referenced before. Then I have data frame. So if well, I don't want us to be walking through if this if you grab what is happening, but just go through one by one. This I believe if I learn data science, this some of these things might have already been talked about on how to work with pandas, how to work with NumPy, how do we work with matplotlib and those things. So I have pd.data. My data again is iris. And if you check, sorry, I'm going to it. So let me just, so the column that we're looking at, it's really good. Some of the features that this gives us. Again, okay, the student, I think I'll just explain this later. Feature name. Now, what we are doing is we are trying to put our data, the data that we have here, which is the iris data set, and put it in a data frame. Now, if you check the beginning of our data here, it shows data, and then it says an array with this. So what this is basically saying is that this was a NumPy array or a Python array, and then it loads all the data inside it. So it doesn't make sense like that. So what we're trying to do is to have our data, identify the data as the main array, which is the array of data as you can see here, and then the feature column, which has this setter length, beta width, is going to be our columns. So run this. Right. That's it. Oh, there's an error there. So let me check. It's okay. With these feature names. So that is done. So now, so let's go to the main thing now. So one thing we can do whenever we have our data frame set up is to query our setup. We can query our data frame and what is actually inside this data. And how do we do that? We can use iris df. We can use the info method. So the info method is going to give us some bit of information about our data sets. So if I run this, so it gives me this particular value that I have column non separate length, that's the first column, separate width, peta length, and then peta width. It tells me that that's I have 150 not null. That's 150 data that is not null, and type of data that I have there is float, not integer. So this info just gives a basic information about our data set and then how the whole thing looks like. Though I did it here and doesn't make sense. So one thing I can do is to again come down and use. You see that it makes sense now with df instead of using it with iris directly, and I put head. So iris df dot edge. So you can see that it makes sense now. So do you now see the reason why we have to convert this to data frame? Why this line is very important. When we use iris directly, this was this just dump of data, but putting it in the data frames enable us to use pandas to analyze it very well, and then it gives more sense as if you are working with Excel. So now, dot head we show us the first 5 rows. So we have row 0 to row 4. The first one is separate length, separate width, peta length, and then peta width. So with this now, we have much more better visualization of how our data looks. and then we don't have to worry about some bunch of data again. So this is also the same applicable if you want to see the last 5 values. I can just maybe copy this and then put tail. Head is the head and then tail is the tail. So this is the last 5 values. Again, let's try to connect all these things together and how they mix. If I go back up, where I press .info, it shows me I have 450 rows. And if you check here, the last number is 149. So, but what that means is that it starts from 0. You can see the first column is 0, not 1. So if this is 150, it will start from 0 and ends on 149. So we have basic representation of what our what our data looks like. So that's the first thing. That's the first thing we have to do as a data analyst. Just try to look at our data and then see what's actually in data at all. Again, another important library that we use for data analytics is NumPy. So I can bring this in. Now it's time to use NumPy as NP. So the same thing that we did for pandas. Again, we are importing NumPy as NP. But in this case, I don't want to use the iris dataset again. This is just to see how pandas work. I'll now start creating my data. So we can have, let me call this example 1. Let's say you have some data sets. I'm trying to create my own data set now in this case. So the first element is 2. Let's say the second element is none. We have 6. And then we have 8. So what are we trying to look at in this case? When I was presenting the slide, I spoke about missing data. How do you undo missing data in Python? How do you undo missing and duplicate data? Now, there are 2 different ways you can see a missing data or duplicate data. It can be none or none. None is like, it is not a floating point. It's not a floating point number, so it can be there. None is not a number. Let's say you have strings, whatever is not a number, like true or false. So those are none, like not a number, none. And we also have none. So if I run this, I have my data, which is 2, none, 6, and 8. But the reality here is that normally Python is going to allow us to have this kind of data. I can have 2, none, 6, 8. But you all know that this doesn't make sense. Let's say you are trying to collect the age of people. The first age is 2, the third age is 6, and the last age is 8. But you have an age that is none, like there's nothing there. Let's just say that like there's nothing there. If it's actually a human being, it's sure that the person has to have an age. So this doesn't make sense, even though Python will allow us to create it. But if you want to do some things with this data, it won't work. Let's say you want to add up all the numbers. Let's say you want to add up all the ages, or let's say it's height data or any form of data at all. Let's say you want to add it up. So you can say exam1 dot sum. So I'm trying to create a sum of all the ages that I've collected. And then we run into problem. It's telling us that it can't find the sum of all the ages. Even though I was able to create it, but I can't find the sum. So whenever you are handling your data, you might be having cases like this, that you have some cells that are not actually the numbers that you want. You can have maybe a letter instead of a number. You ask somebody to type their age, they put their name there. No, you have this kind of scenario where handling a company's data or a research data. So it's now left to you now to know how to handle all this data. I said the first case is none, another case is also none. But let's leave those ones now and then look at them later on. So let's say we have another case of none. So I can say example 2. Please, those are the 2 scenarios that we have. It can either be none or none. So let's create a series. In this case, let's create panda series. Let's say the first one is 0. We have np.none. So this is like not a number. Again, let's use empty cell, and let's use none. Now, yes, this is a full data frame in pandas. So you have 0, you have not a number, you have a string, then we have none. No, I said we can create this without any problem. So I mentioned that there are three ways we can, there are four ways that we can check this. We can use is null, we can use not null, we can use drop null, and then we can use fill null. So let's check. This same thing you are going to do also if you have your own data set. You can try to check how many of these cells are actually empty. You want to analyze your data, so you are checking out how many of my data set is actually empty. Because if you are going to create a graph or you are going to add them, like we saw in the previous example, you won't be able to add. So first you have to make sure you clean that there's no any bad data there. So the first function that we look at is null. So you can have example 3 dot is null. So you are trying to check how many of my data is actually bad, like it's not, doesn't make sense. Exam is exam no p. Exam, oh, exam 2. So yes, and we have this. Now, if we check, I have 4 elements in this data, 0, np. So it shows me that first one is false, meaning that it is actually a real data. Second one, which is np.none, it said is bad. That's true. That is null. That is not actually real data. That's null. It tells me that the third one is actually false, which is this. So though it's a string, but it's still it's still a valid data. It's not a floating point like the first one or the second or 1.2, but it's still a real data. So it's showing that it's false. And then we have none, which we have seen before, showing that it's false. So with this now, I can know the type of part of my data that is null and part that is bad. So now sometimes you can choose to drop null. So that's the first thing. So what if you want to, that's the first thing you might want to do. Let's say you want to drop all the bad elements of the data. So you can use the exam2 dot drop. This is the second thing that we looked at while presenting the slide. Drop now. So you have exam2 dot drop now. So this is going to drop all the part that says true here. So our data now remain what? Just 0 and 2. At index 0, we have 0, and then at index 2, we have a empty data point, just like what we have here, just like empty string. So that's one way of handling it. You can choose to drop, and that's what we just did here. So let me also create another one so that we have more intuitive example. Let's say we have example 3. This example 3. So I want something that makes more sense now. Dot data frame. What I want here is 1. This is my first row, and then let's say we are creating a non value, and then we have 7. By 8, and then lastly we have np.none. Same data that we have, though just 3 by 3, 9. Let's take time. Okay, so let's examine it. Exam 3. Let's see what we have. So we have this 197,259 and this. So there are things we can do. As I said, you can choose to drop the non-numbers, which is using the drop now. This is actually dependent on you. Sometimes you want to drop, most times we drop by row. So if I use drop now, for example, there's row 2, there's a non-value, it will drop everything on this row. Row 1, there's no any non-value, so it will leave this. And also in row 0, there is a non-value here, so it will drop everything. If you want to drop it by column. We can also do that. So let's say we want to drop, if there's a bad value in column 1, we want to drop all the columns. If there's a non-value in column 0, we want to drop all the columns. So, but the default is by row. So if you have exam 3 dot drop now, so you see it drops by row. But if I wanted to drop by column, I'll just put again the same thing, example 3 dot drop now. But in this case, I set up my axis to be equal to columns. So it's going to drop by columns. So it has dropped column 0 and column 1. I only have column 2 left. So again, that's also dependent on you. Do you want to drop by column or do you want to drop by row? So we have all those different things that can happen. And that thing, as I said, we can do is to fill up. We can choose to fill up our data set with a particular number. We can choose to fill with 0, or you can choose to fill with 1, or you can choose to fill with anything at all. So let's say you want to fill all the non-value with 0. Yes, that's one thing that is common. Let's say you want to fill everything with 0. So you can say exam 3 dot fill. So this is the optional dot fill now, and then 0. So if I run this down, so you can see that all those bad points has been filled with 0. So again, you can just just fill it with whatever you want. Let's say you want to fill everything with 1. If I put 1 here, it's going to fill everything with 1. So this is actually dependent on the data you're looking at and what you need to do with data. Please, this is dependent on us and what we want to do. So it's left to you as a data analyst to know what to do. Sometimes you want to fill with mean of the value. Sometimes you want to fill with maybe some other values. Sometimes you want to maybe just fill it with the last value or fill it with the value above it. So you can choose to do anything at all you want with your data set. You do different things. If you have duplicate also, you can choose to drop duplicate, or you can choose to just leave them there. Yeah. And it's this let's do an example of this. But the point that usually use here is drop duplicate. Duplicate in the data set, you can just use the function drop duplicate to drop all the duplicate that you have in your data set. And with that, so once your data is ready, and then we have everything prepared, there's no non-value, there's no duplicates, or there are duplicates. Once you're satisfied with data and how it looks, then you can go into the analysis and try to make it presentable to your audience. So going to the analysis now, I have a data set that I want to use here. It's housing data set. So I have it here as form of CSV. So I'll just use it for my analysis. So this data set has been prepared, it has been cleaned, it has been analyzed. So I don't have duplicate value, I don't have non-value, I've already made all those things that I mentioned earlier. It has been cleared, everything has been well cleaned, the data is well suited for what I want to use it for. Then I can proceed to the analysis. So what I will do is to first import data and into the data frame. So I can say df equal to, again I'll use pandas. Pandas is very useful. So pandas dot read, I'm going to read it CSV, and then I will load it up. It's currently inside my data directory slash, and then I call it housing.csv. So let's say if you want to check edge, just like we said the other time, you can put df.edge. So you have the data sets here. So each of all these things actually make a particular sense. This rate pattern, land. Also, they all makes sense. What the MEDV means. This particular last column, MEDV, shows the median value of owner occupied homes in $1,000. So for this case now, we have this particular data set. You can see there's no any none or none there. Everything is very clean. Again, if I show detail, I have the same thing. The data is well prepared and everything is okay. And then I can proceed with my analysis. So the first thing I want to do as a data analyst is to check what's in my data at all. So I can check df.shape. Shape is going to give me the length and breadth of my data. So 506/13 is showing me that I have 506 rows and 13 columns in this data set. 506 rows and 13 columns. So with that, I have at least if one information of what I have in my data set. And that has to do is to describe. I can say df.describe. So df.describe is going to give me at least some pre-information of what my data set is. So here we have, it shows all the columns, and then it shows the count, the mean, standard deviation, the minimum, the 25 percentile, 50 percentile, 75 percentile, and then the max. At least I have some information about the meta set, but just looking at this, I know the mean of all the columns, and I know the count of all the columns, I know the standard deviation. Now it's now up to you using descriptive statistics to know what does standard deviation actually mean, what does the mean mean, what does the 25 percentile mean, what does the 50 percentile mean, that's the mean, the 75 percentile mean, and what does the max mean. And if you want to make your prediction, you're able to make it. Let's say you're looking at stock exchange data or share data. So you should know that the values of standard deviation makes a lot of sense in stock. Let's say you are comparing Amazon stocks with Nvidia stocks. I can say that the standard deviation is invest into shares that they don't deviate at all. What it means is that if Nvidia share goes up, Microsoft share also goes up. If Nvidia share goes down, Microsoft share also goes down. No. So if you know that standard deviation is one, you should know that you know to know that's like highly, that it will be zero. That's like no, they don't defeat. So you want a stock that at least if one of these stock fall and that one is rising. So you should know what all those things mean so that you're able to make prediction based on what is required. So sometimes you want it you want to have a big standard deviation and sometimes you want a very small one. Just depending on the data you are looking at. So let's say I want to look at the mean, just the mean of this last column. Again, I can just type in df and then I will select the column that I want. In this case, I want the column MEDV, MEDV, so dot mean. So, and I have 22.53. So what this means is that the mean of this particular column is 22.53. As you can see also, is 22.53. So instead of looking at everything in a go, I can just choose to look at the mean of the last column, and it shows me that it's 22.53. Again, you can look at the max, like what's the maximum number on this list. So it shows me that it is 50 instead of going through everything one after the other. Again, if I put median, I have 21.2. I will check here, it shows that 50 percentile. Please let's do some discrete statistics. In statistics, we have percentile and then we have decile. 50 percentile is we have quartile, we have decile, and we have percentile. So second quartile, that's the median. That's it. Like second quarter, like half of our data. That's the median. So second quartile, 50 percentile, and median, they all mean the same thing. Second quartile, 50 percentile, and median, they all mean the same thing. As you can check here, when I calculated median, I have 21.2. If you check the 50 percentile also, it is 21.2. So that's like 50% of my data. That's like half of data, or the median, or the second quartile. So that's why most times in statistics, we don't calculate the second quartile. We only calculate first quartile and third quartile and the semi-interquartile range. So because second quartile is also the same thing as the median. So you can also descend, let's say you want this thing for multiple columns, like you want it for the age, you want it for the you can also do the same thing. dot by it's going to group by this, yeah. So by the age, let's say I want age, and then I want to calculate the mean of this, and error n group by mean, not mean that shows age. This particular column. So it's showing me the age.
Good evening. I think our presenter's network has
Can you hear me? Can you, since my screen stopped sharing and then you can't hear me again?
yeah, you went quiet. It's now we start hearing.
Please, can you, if you can react, if you can still hear me, can you react if you can still hear me? Yeah. But can you see my screen? I don't know if my screen is still sharing.
No, your screen is not sharing.
No, you're no longer sharing your screen. We can't see your screen.
Okay, you can see. Let me try to bring it up again. Let me try to bring this back up. God, I think it's network. I'm trying to share the screen, but it's not sharing. I'm trying to bring it up, it's still not sharing. I think, can you able to check it?
Hello? Samuel?
I think I can't hear you.
Can
You're
you hear
talking,
me?
but it seems I can't see. My screen stops sharing. I'm trying to bring it back up. Yes, we can hear you. We can hear you.
Okay, I think it might be a network issue. And this is 2 minutes out from time.
Mr. Sam, I think you can continue. Then you share the slide after the class. You can share the slide after the class.
Okay. Okay, yeah, I think it's up now.
Yes, it is up. We can see your screen now.
Yes, your screen is visible now. It's clear.
Oh, well, you're muted. You're muted.
But can you hear me now?
You're muted.
You can proceed. Your screen is visible.
Yes, but you are muted, Samuel. You're.
Okay. Good. Can you hear me now?
Yes, we can hear you.
Yes, we can hear you.
Okay. So dot value count. Oh, what's the problem? Page 50 dot value count. So value count, sorry. So value count. So what this shows me is that number of houses that are older than 50 years old is 359. And houses that are lesser than that are not that's false. It's 147. So we can do all these, find the main median mode based on the question that is being asked on our data. So another thing we can do is to check for unique and then the non-unique values. But no, without looking at that, let's just go straight into the what I was talking about the other time about correlation. And let's say you're looking at we're looking at stock data. So Another thing we can do is to find for correlation. It's very important. We usually do this a lot. So correlation, you can see the method. So what I'm trying to find now is the correlation between my data sets. Let's say this is stock exchange data. I can actually find correlation and see which stock should I invest in and which one should I not invest in. And yeah, this shows us how each of the data points correlate to each other. One shows correlation, the one usually the max number, and zero is the minimum number. So zero is that standard deviation. I mean, correlation is how do they relate to each other. If something happens to data A, what will happen to data B? Like if A goes up, if B also goes up, that's like the correlates that they really correlate. And if B goes down, let's say C goes up, meaning that they don't correlate at all. So if the correlation is one, meaning that they correlate together, whatever happens to A, will also happen to B also. And if it is zero, like they don't correlate at all. So this shows us how our data correlates. This sin, cream, and cream, they are the same data sets. So they are the same point. You can say that they really correlate, since it's like the same thing, they correlate now. So what we have to compare is, how does the sin correlate with cream? So minus shows us that if it goes up, this one maybe like go down in the opposite direction. So this shows us how our data sets correlate. Let's say you are looking at Nvidia and Microsoft data, as I mentioned before. You can check for the correlation over the past 5 years. Whenever this thing happens to Nvidia stocks, what happens to Microsoft stocks? So another thing we can use in this case is Seaborn. Seaborn is another library in Python that we can use to analyze our data. Seaborn, and check. So let me call this SNS. So let's say I want to bring up again the correlation data. I want to see how they correlate, but in this case using heatmap. So you can have SNS dot heatmap. I want to use heatmap in this case. Dot heatmap. So DF. So I'm bringing the correlation data now into play. So correlation, and then my CMap is going to be in SNS. Dot Q palette. Yes, so 20. Fine. So what I'm trying to do is I want to generate a heat map to show how my data correlate. So what I did before is to just generate numbers, but with this data I want to generate heat map. If it's very dark, mean that they really correlate. If it's very light, they don't correlate. So if I run this, so I have a heat map that shows how my data correlates to each other. So you can see the things around along the diagonal to be very dark, meaning that they're actually comparing the same data. And every other one, if it's very light, meaning that they don't correlate at all. And if it's very dark, they will correlate. So this is a much more easier presentation to show how my data actually correlates to each other. Yes, to show how my data correlates to each other. So we can generate different graphs like that based on what we are trying to analyze, and based on what we are trying to get our shareholders to understand. Another thing we can use is histogram. As I mentioned earlier, you can use histogram. And another library that we can use for this is matplotlib. So you can import matplotlib.pyplot as PLT. And let's say you want to plot the histogram of the med view data. So you have DF. So in this case, we want the MAD view data. And if I run this, I have the histogram of the last column of my data sets that shows how they relate to each other. So from this histogram, I can make some presentations. I'm able to make sense of, okay, over the course of the years, there's a particular year. This is not year now, but in this particular case, you can ask question: how come the median price actually shoot up at this level, and how come it goes down? We can ask questions based on this. What does this perform like this? Let's say you are looking at our sales for this year, and then you have a particular month that our sales shoot up. So you can ask questions: how come our sales shoot up at this particular year, at this particular month? What were we doing to make it increase like this? So therefore, if you can get our sales to go up at this particular month, we can also keep on doing the same thing for the rest of the month. So we can make that kind of presentation and talk about that. Again, you can create this plot. So this is going to give us like a trend line. So DNS dot this plot. I said the most important thing for you as a data analyst to know the importance and then the advantage of each of these plots and what they actually mean. So by looking at descriptive statistics and also inferential statistics. So let's say we want to generate a disk plot from SNS. So this shows us a form of plot. It looks very much similar to the plot that we have above. That's the histogram plot. But in this case, we have much more bins. That's those rectangles are now more in this case compared to the other. So I'm expecting this to give us a trend line. But if it's not there, you can maybe just ignore it. So another thing we can do that's very common is to have scatter plots. Whenever you're looking at machine learning, this is very common. Looking at scatter plots. So you can also maybe generate a scatter plot using join plots. Let's say you want to compare two of these points. For scatter plots, we have to always compare two data points. So let's say you want to compare the RM and then the med V, that's the median value of the prices. So we can have DF RM, and then the other one that we're comparing, which is the med V. So you just have to give it here that the kind, if I type only this, it's going to maybe try to generate some, it's asking, it doesn't really know what I want to do. So what I have to do is to tell it that I want a kind of scatter plot. Scatter. Yeah, it's an error somewhere. Giant plots, yes. Kind of scatter. It says giant plot takes from 0 to square argument, but 2 arguments were given. It's actually 2 arguments. Why is it saying joint plots? DF, I mean, DF med V. The kind is scatter. It's supposed to work. I'm surprised the error is it takes 0 to 1 arguments, but 2 are given.
I think you need to put X positional argument.
Yes, from it says it takes 0 to 1 positional argument, but two positional arguments were given. They just want equal to there. If I remove 1, wow, I'm surprised, but it's supposed to work the other way around. This is not what I was actually expecting it to give me. So I want to have the same thing that I have on the right hand side by the top. So it's give me like plots at the right hand and then at the top part. But no, maybe there's an upgrade or something to the library. So this is another type of plot that you can generate. This shows us both the scatter plots and then the histogram. So we can say that at this particular point, we have a lot of concentration of our data points. So the question is that what does this mean? In most times, we will not present our data set to stakeholders or to investors using scatter plot. But whenever we are dealing with machine learning or want to build a model, we may have to use scatter plots to see how our data relate to each other and how you can draw the line of best fit to make predictions from our model. So that's another form of data that we can generate from our data, from our data set. You can also have you can also generate like a form of regression data for different lines. And this will be the last thing that I want to do. Let's say I want to they call it peer plots. So you can generate peer plot using SNS again. So what I'm going to do here is I want to generate a plot for the RM. Let's say again for age. And also I'll be looking at the med v. This is what I did the other time too. So in this case, the kind is not scatter plot again. So we want it to be like a form of regression plot that we use in data analysis. So regression here. Mm, so I'm trying to sorry for the hold up. So the kind is regression. I just want this to give me some anyway. So I'm going to explain this. Let me just bring it up. So the color is going to be red. Right, and then it's going to be scattered also. The KWS. We have the alpha value like we said the other time. Again, okay, there's an error there. It's in mid v h. Okay, this is supposed to be comma. Yeah. Hey, there's a lot of errors. Scatter, okay, scatter is supposed to be 32T. Yes, so here we have the plot that shows how each of the data correlate to each other by drawing a straight line graph. As you can see, it shows here we can easily make prediction. You can see the straight line graph from here, again from this particular data also, and then we can see, what this gives us is that it plots like a form of scatter plot, and then draw the line of best fit. So with this, we can transfer this to our machine learning workload or to our artificial intelligence workload to find the line of best fit and be able to make prediction on our data. So this can vary from the data set you are looking at, depending on what you are looking at, depending on what you are doing, depending on the data set at all. You may have to generate different form of graph and different form of analysis. You may have to calculate mean, median, mode. Sometimes you may have so this is going to help you to know what to do to your data at any given time. And I think that's the most important part of the whole data workload. Knowing what to do with your data and how to analyze it is not really a big problem. It's basically what you need to do to data and how do you do those things. Yeah. Thank you so much. I think that's right about it regarding analyzing your data using Python. So if you have, we take the questions now. If you have maybe some question or information or maybe some suggestion around what you just see or request for resources, you just take that now. You can maybe drop it in the chat section or you can unmute your mic. Again, we are going to be sharing the link. That's the slide. So from the slide, all the prerequisites that I mentioned in the second slide, the links to them are on the second slide. So we can go through the slide, click on the link, and then we have access to those resources on how to set up our laptop and how to set up Visual Studio for data science. So again, if I don't know if there are questions or comments or maybe what is not clear during the session. Umar Mahmoud, you want to say something? Can you unmute yourself? I think yes, Mahmoud.
Yeah. Good evening.
Yeah, good
Mr.
evening.
Samo. Actually, yeah, that's a very nice session. I really enjoyed it. My question is this session recorded? Can we actually get access after this maybe to maybe look at the recorded session or something like that? That's wonderful though, but I'm just asking about that. Thank you.
The session is recorded and it will be forwarded to your emails after this session. The session is recorded. Both the slide and the recorded version will be forwarded to.
Thank you very much.
Yes, thanks. So I think that's right about